Bonjour, welcome. Good to see you today. This is going to be question 12 of your stoichiometry notes. I showed question 11 in another video. They're both limiting reactant problems. I showed limiting reactant in terms of moles in the last one, so finding that in moles, and seeing if they're in a 1-to-4 ratio. This one I call going to a product method, so getting grams of a product. So I'm going to start stoichiometry off with this and go to grams of one of these products, and then start off with this and go to grams of the same product. Whichever one produces lesser amount of the product is our limiting reactant. So question 12 wants you to know how many moles of water could be produced. Usually I'll ask you how many grams, but in this case I'm asking you a number of moles. So we're trying to get to moles of this. So again, I don't know which of these is going to run out first. They're probably not in the right ratios in terms of moles. They're supposed to be in a 1-to-4 ratio. So I'm going to take this one to moles of water and take that one to moles of water. So two stoichiometry problems here. So the first one I'm going to start with 200 grams of SiO2. It is 60 grams per mole. Do my ratio for every 1 mole of SiO2. There's 2 moles of water produced. Okay. Again, I could go to grams, which means I'd have to do the molar mass of water after that. So that's about 6.67 moles of water. That's how much water could be produced if SiO2 is the limiting reactant. If it's not, if it's the one in excess, that's going to be more water than we could get from this reaction. So now I'll do the same thing with the 400 grams of hydrogen fluoride. It's 20 grams per mole. The ratio is 4 to 2. For every 4 moles of HF, there's 2 moles of water. When we do that, we get 10 moles of water. Again, that's if HF is the limiting reactant, the one that's going to run out first. Well, whichever one produces less product is your limiting reactant. So this is the amount of water we could produce. That means that SO2 is our limiting reactant. It's going to run out first. You can produce less water from it. So this could not be produced. That's not an answer like anything. It's only how much water could be produced if we had plenty of SiO2 with the HF, and we don't have enough of that. So that tells me then that HF is in excess. There's more HF than we need. So the other question on there is, what is the mass of excess left over? So there is extra of this. This is our limiting reactant. So we need to figure out how much of this is used. So say 300 grams is used, that means there's 100 left over. So whenever I do this, start your stoichiometry always with your limiting. I'm going to go to grams that, now tell me how much is used. So I'm going to say I got 200 grams of SiO2, 60 grams is a mole. So my grams and grams cancel. Do my ratio. For every 1 mole, there's 4. For every 1 mole of SiO2, there's 4 moles of HF, and moles cancel. And then say that every mole of hydrogen fluoride is 20 grams of hydrogen fluoride. When we do that, we get an answer of 266.7. So we'll say 267 grams of hydrogen fluoride. Again, that is how much hydrogen fluoride we would use if we use 200 grams of silicon dioxide. So that is the amount used. The amount of excess would be, we had 400 grams of that, we're using that much, so 400 minus 267. 400 minus 267, which is going to give us about 133 grams of excess. So we have 133 grams of extra HF that's not used because we ran out of SiO2 to react with it. Thanks for coming today. Have a great day. Have a safe weekend. Have a safe rest of the year.